crystals. And before your imagination runs wild, I'm not referring to the one made by Walter White, the chemistry teacher of Breaking Bad. The ones I'm referring to are which has held the fascination of mankind for their beauty from time immemorial. Gazing into a crystal ball supposedly foretells one's future. Crystals are also believed to have mystical healing powers. Diamonds, rocks, snowflakes, even your day-to-day that you use, your salt and sugar, are all crystals. They are solids with a well-defined shape and size. These are large selenite crystals growing in the caves of Mexico in the Nika mine. And as you can see here, they are at least 5 times larger than any living being, than the human person there. So, talking about these different forms of crystals today, what I am going to talk about are my babies. Protein crystals. So, these protein crystals are even more fascinating than the diamonds or anything else more precious, because they have a wealth of information stored in them, and studying these crystals will allow you to study the function of how they work and how it works in the body. And to make protein crystals, what do we need? Proteins. So all of us are familiar with proteins. The fad foods of the present day. A protein-rich diet makes you supposed to be, very good and makes you feel fit. Protein powders, protein shakes, protein bars. Oh, hot property on the shelves of the supermarket, which just go off. So, these proteins, what are they? They are the machinery of life, present in every living form. Something as minute and small as a virus, through to the plants and animals, or even to the extinct and the enormous dinosaurs. Everything, every being is made up of proteins. And what are proteins made of? They are made of 20 naturally occurring amino acids, which are the building blocks of every protein. Just as we have the 26 letters of the English alphabet, which gives rise to the millions of words and everyday new words forming and developing, or even the 7 notes of the music, which can create a multitude of melodies and symphonies, it is the permutation and combination of these amino acids which give rise to the vast number of proteins, each very specific, doing their job. We are all people. Yeah, we have the same external organs as well as the internal organs. But we look different, we behave different too. Same is the case with proteins. They are all proteins, all made of the amino acids, but each of them behave different. When something goes wrong with a protein, what happens? We become ill. So, to understand what that protein is doing, we need to study it. And it is for this reason we grow crystals of proteins. And that is what I do in my research. Now, proteins in their natural habitat in the body or any living form are in a liquid state. They are molecules dancing away in the water that they are surrounded by. And I am trying to convince them to come out as a solid. And in this instance, I want them as a crystalline solid. Why? We've all heard of the term crystal clear, or to crystallize one's thoughts and ideas. It stems from this science of crystals. So you also need the proteins in your crystalline form. So to convince these proteins to come out from their liquid state into a solid state, I apply a formula. And that is invented by me, by the way. C square, P square, S formula. Now, if you're wondering what this is, it is not a mind-boggling, complicated mathematical equation whatsoever. All that it means is coax, cajole, plead, pray, and if all of that fails, sing. And to my proteins, I sing my favorite Bollywood music. Will you be my chammak chalo? And what happens? They don't come out. So next you might be wondering, okay, why do you want these proteins in a solid? For what? Now, when you go to have an X-ray, in an X-ray scan, one can see the rib cage and the bones, but one cannot see the blood and its components. Same way, when the proteins are in this liquid state, we cannot understand their function fully. And therefore, we need to solidify them and make them into crystals. And these crystals are then subjected to X-rays in this huge ring-like structure that you see here. They're very special facilities. So you take your crystals and then you bombard them with X-rays. And from that, your useful data that you collect, you then use that to study their function. So this picture that you see here is a state-of-the-art facility called the Diamond Light Source, and it is near Oxford. And once you go there, you end up doing so many night shifts, 24 hours, round the clock, getting your data. And once we collect this data from your crystals, the pharmaceutical industry then uses this data to develop and design drugs. Now, it takes around 15 years before a drug comes into the market. It has to go through this pipeline, through the various stages. And what I do is very important to feed into this pipeline way before the discovery stage. So unless I provide this drug pipeline, the structural information, only then the pharmaceutical industry uses that to process further, and then it gets fed into this pipeline. And that is how drugs are made. At a recent science festival, a visitor came to us and we were just showing her this pipeline, and she was undergoing cancer therapy and was totally taken aback at the amount of research and development that goes behind in making one single medicine. And she said, from now on, I will look at my medicine in a different light and learn to respect it more. So, growing protein crystals is not rocket science, but crystallization experiments were set up in rockets as well and sent up into space. So there she is, my guru and mentor, Professor Naomi Chayen, who has set up a number of such experiments in space shuttles which have gone up there. And once the crystallization experiments are sent up into space, There is a belief that you have bigger and better crystals because the protein molecules in that liquid state are in a lesser stress environment and that the gravitational force is far reduced as compared to what you have on Earth because they are being pulled in all directions with the various forces. So once you have better quality crystals, one can study them even to a finer detail. And these are the examples of the very vital enzyme, insulin, yeah, for diabetes, which was sent up into space. And you can see here in this picture how different the earth-grown crystals are from the space-grown crystals. And this helped the scientists to study this enzyme, the hormone, to a much better detail. Okay, coming back down to earth, into the oceans and the sea and the creatures in them. Lobsters. Lobsters in their natural environment are blue in color. And this is because of a protein called crustacyanin. When the lobster is cooked, it changes to, you've seen that, to red. And why is this? This is because there is a pigment attached to this protein, which is red in color, and when you boil the lobster, the pigment falls off, lending the lobster its red color. This pigment, known as astaxanthin, is an antioxidant and is known to combat cancer, dementia, aging, and many other illnesses. The role of crustacyanin is to act as a carrier to carry this astaxanthin into the body tissues. And therefore, when we studied the crystal structure of this crustacyanin, it helped in developing more drugs to fight these illnesses. A decade ago, during my PhD project, I was working on a protein implicated in cardiomyopathy, a heart disease. Final year of project, totally stressed out. No conclusive result. Make and break project. What do I do now? Will I get a PhD or not? So dejected, despondent, at my wit's end, just didn't know what to do. Said, okay, the best thing is to go off on a holiday. So before going off, setting off, set up some final round of experiments and went away to Switzerland. Trying to forget what's happening, what's cooking in the lab there. And guess what happens? On return, what do I see when I take my tray to look under the microscope? Crystals of joy! Yay! Eureka! Took these up to our synchrotron source and collected the data, and we solved the structure of it. And till date, this is the only crystal structure of this protein, and this protein is called the cardiac myosin binding protein C. 10 years on, I am still here, same lab, same experiments, different proteins. And these are some of the crystals in our current project. And cracking their mystery has the potential to develop drugs for AIDS therapy. So these are the crystals. And so what do I want to convey now from this is, more often than not, protein crystallization doesn't give you a positive outcome. 99% of the time, you have no success whatsoever. But then you keep trying and trying and trying. And the day when you go to check your experiments under the microscope, and when you see these crystals, oh, I know why I'm doing this, is what I feel. No words can express the feeling of joy and elation when you grow these crystals and collect the useful data from them and finally help in the development and design of drugs for the betterment of mankind. Marilyn Monroe claimed, "Diamonds are a girl's best friend." And we want to modify that and add to it and say, "Crystals are everyone's friends." And thank you for your attention.